Okay, welcome back to CS196. Today we're doing Rust Lecture 3. So let's go over the objectives for today. Firstly, we want to do slice types and string slices. So this is building off of ownership and memory accessing, which Sami talked about on Tuesday. We're going to talk about structs, which are a very useful type of data type that you can create yourself. And then we're doing a big Kahoot review with a lot of questions from everything we've covered so far. And that's also going to be worth 1% of extra credit for people who are in top 5. So stay focused. A lot of questions are going to be from today. So let's start off with what a slice is. So slices allow us to reference contiguous sequence of elements in a collection instead of just getting the whole collection. So let's talk about it over here. If we have from last week's lecture hello like this is the whole collection in memory or in the heap. But let's say we don't want hello, we just want the last 3 letters. That's called a slice, like this. So let's talk about how we can get this and why this is useful. So firstly, slices are references. So that means they do not have ownership over what you're getting. And a way we can use slices is, let's say we have like a long string, like a very long message, and we want to get just the first word. Or let's say we want to find the first occurrence of a specific word and the word right after it. So that's where we can use slices. So a string slice is a reference to a part of a string. So they look like regular references except for the very end. So notice that you have the square brackets with 2 numbers, dots. It's kind of a weird looking format. But this part makes it very, very useful. So a string is essentially an array of characters. So an array is a list. So we've seen lists before, pretty basic stuff. Is there any questions about arrays before I move on? Right, just a regular sequence of characters. So let's say we have an array or a list of characters called reverse me, like this. And now we have all the indexes. So if it's an array, we have indexes 0 to the last length. So index 0 has R, index 1 is E, etc., etc. So 0 to 7 means we want the characters between the 0th index up to, but not including, the 7th index. So in this case, we're going to get 0 up until, so it's R up until E, so the first word reverse. We don't get the very last index. That's exclusive. So let's see this in practice, because I think it's the best way to actually work with this. So I already prepared this beforehand, so we can just get this up. So we have here a string slice. So we're declaring a variable called reverse me, and it's just the string reverse me. Reverse with a space, me. And we declare word 1, which is a string slice of reverse me, with these parameters, and word 2 with this parameters. So does anyone have to take a guess at what the print will do? Nope, okay, we can just run it then. Me reverse. All right, so let's talk about what happened here. So firstly, we got the first word, which was reverse. So we went from 0 to 1. So if we count from here, we have 0, 1, 2, 3, 4, 5, 6, and 7 is the last one, so we ignore it. Similarly, we start from 8. So 8 starts here, 9, 10. So 8, 9, and then 10 is the last one. We ignore it. And we just printed them, but in reverse order. Simple stuff. Any questions about this? Okay. So internally, what a string slice is essentially, it's a data structure that stores the starting position and the length of the slice, which is the ending index minus the starting index. So the word2 variable contains a pointer to the 9th byte in reverse me, and it's a length of 10 minus 8, which is 2. So the reason it's 9th, not 8, is because we started at 0. So let me explain that graphically since it's easier. So let's say in memory in the heap we have this reverse me over here. So we can see it goes from 0 to 9, and it has each byte is stored in a different area in the heap. Reverse me over there is the string, and word 2 is the slice. So notice that they have something called a pointer. A pointer is a variable that just points to a section of memory. Similarly, how you see integers, like if you have an int, it holds a number, string holds a string. A pointer is a very specific type of variable that holds a memory location. So it lets us know where to look in memory. So reverse me, the actual string, points to the start of the string. That makes sense. We want the full string. And that this holds the pointer, the length of the string and the capacity. So we'll talk about capacity later on when we talk about vectors and such. All you have to know is that it has a length of 9. And now we have word 2, which was me. And this pointer starts at the 8th index, or the 9th byte from the start, and has a length of 2, because 10 minus 8 is 2. Does that make sense, how this works graphically? Yep, great. So using notation ... we can do a few clever things. And let's say we want to slice a string s. So we have the string s, and let's slice it up in a bunch of weird ways. So let's say we want to go from 0 to the 5th index. We can just do s ... and then the index. If we don't say anything at the start, Rust knows we want 0 automatically. And this is just a quick way of doing that. Similarly, if we want to go from any random index to the end, instead of finding out the length of the string, calculating that, storing in a variable, all that mumbo jumbo, we can just do some index ... and then don't put anything after that. Close the bracket. That way, Rust knows we want to go from some index to the very end of the string. Also, because we have this ... notation, we can also just do ... and get the whole string. So let's say we wanted to get a reference of the whole string. We could just do a slice type, but have it be ... So a few other key points is the string slice has a specific type, and that's ampersand pointer, because it's a reference, and it's like a string. So this is when you want to, in a function, for instance, have a return type that is a string slice, or you want to have a parameter that's a string slice. And string literals are also string slices. So if you declare a string like this, so let's say a random string called literal and make it literal. So this is not a string with like varying size. This is actually a string slice. It's a reference to a location in memory. And it's also why it's immutable. It's because a string slice is, by default, an immutable reference, as are all other references. Let's talk about other slices, though, because slicing is very useful not just for strings. We can actually slice in other collections like arrays. So for example, here we have an array called SumArray, which has a bunch of random numbers in there that have no meaning. And then we have letSlice, which is a slice of this array. And we're going from 1 to 3. So that means we get the first and second index. So slice now a reference to 9, 6. Does that make sense? All right. Now let's talk about structs. So structs is a custom data type that allows you to group a set of values that make a meaningful group. So this is different from a collection. A collection is often just like a list or a tuple or array. It could be anything, whereas a struct will be a single variable that holds a bunch of values that are meaningful. So for instance, let's say we want to store UIUC students in structs. So the student struct would store the name, the UIN, are they a 196 student, and their GPA. And these different values are all different. They aren't the same type, clearly, but they're all related to one thing, and they're all meaningful to one group. So let's first declare a struct. So how do we declare a struct? We declare a struct by using the keyword struct followed by the name of the struct, and then 2 curly brackets. And then we do what's known as a key value pair, the key being the name of the variable and then the type of that variable. And we store that in a comma-separated list. So this is our UIUC student struct. We have, obviously, the keyword struct, the name UIUC student, and this is something I learned today, but if you don't capitalize your struct name the way I've done it here, the compiler actually gives you an error saying, are you sure you want to do it like this? There's another way to do it. So something I learned. And then all the values in a key value pair. So the name is a string, the UIN is a number, the integer is a Boolean, and the GPA is a float because it's a decimal. Now let's declare the struct in our code. So how do we do this? So let's say we want to, in our code, declare a new student. So we use the let keyword as we do with any other variable. We call it by the struct name, so UIC student, and then similarly to how we defined the struct, we can declare it in a very similar manner. So our student is called Uintitly 196. I thought it was really funny. I don't know why no one is laughing. The UIN are then 196 in their GPA. Because our new student, it comes in as 4. Oh, so one thing to note here is that let's say you have name, UIN in this order. You don't have to follow that here. Name could be at the bottom, GPA could be second, etc., etc. Okay, accessing values. So we can access values in the struct using dot notation. So similarly with a tuple, if you want to get the second value, you do .1. For a struct, we just do the struct and then the value name. So we have like name, UIN, whatever, we can get the name by doing student1.name. And the output, as we can see, is the student is called U96. Okay, we can also access values in structs. So simply, if we were going to make a variable mutable, we can edit the values using dot notation. So as we know, all variables in Rust are immutable. You cannot change them once you set them. But if we make a mutable student, so student mute over there, we can change their GPA or any other value that they have because this is now a mutable variable. And we can see our output here is that the mutable student's GPA went from 4 to 3.3. They didn't do too well in 125 or something. Okay, very important. So the entire struct must either be mutable or immutable. Individual values inside the struct cannot be individually mutable. So if we look back at the struct over here, or look at this over here, notice that we can just say the name is mutable or the GPA is mutable, although that would make sense. The whole thing either has to be mutable or none of it can be mutable. And that's just for safety when you're writing code, especially concurrent code. And let's talk about using a function to create a struct. So if we want to have a struct data type, it's just going to be the data type that we declared earlier. So if we want to make a struct to declare something, we can do new student with all the parameters that we want and return the struct data type. And we assign all the values inside. And the reason we only have 2 parameters is that because we can hard code values when we create this. We don't have to always be passing a variable. Because let's say we have a new student, they're automatically going to have a GPA 4.0, or they're automatically not going to be in 196. So we don't have to manually assign every value. We can automatically do that by predefining some values. All right, so let's demo this with some actual code. So I made another folder over here called Structs. So over here, we can see we have our struct as we saw in the lecture slides. It's called UAC student and has these 4 values. Give me a second. I have a bunch of other stuff in here. Okay, so let's say we have this function here that we declared. Obviously, what this is going to do is once we pass the parameters over here, it's going to assign that to our new student and then return that student over here. So it creates a new struct, assigns that to the student variable here, and then we can do stuff over here. So we can print out the student's name, UIN, are they in CS196, and then their GPA. So let's run that. Oh, my bad. Oh, my bad. I uncommented my comment. So let's clear this, run that again. And we can see that we have a new student who has this UIN. They're in the non-196, and their GPA coming in is 4.0. They're a new student. But wait, doesn't this seem kind of like a waste of time? Because if we notice, go forward, if we notice the variable name that we're passing into the function, the parameter name, and the parameter UIN is going to be the name and UIN of the struct that we're creating. This is kind of redundant code and makes no sense. But we get this redundant obvious, and so does Rust. So instead of doing that, there's a smarter way called field init shorthand. So init is just short for initialize or initialization. And when the parameters and the field names have the same name, you can just have that, and you don't have to automatically have a key value pair. You can just put name, UIN, and Rust knows automatically that because the field names, the parameter names are the same, to assign those values to each other. But sometimes, let's say we want to make a new struct that uses most of the values in an older struct with a few updates. And for this, we're going to use struct update syntax. So let's say we have this struct over here. So we have a new student whose name is student1, their UIN is that number, their non-196, and their GPA is 4. And we want to make a new student called student2 with these values. So this is what we want. And we could use the dot notation to copy the values from student1, but this is unnecessary code and it can get messy with bigger structs. So there's a better way to do this. We can use what's known as struct update syntax. So notice here, the updated values we manually assign to what we want. So we know that we want a different name and a different UIN. So that we manually assign here. However, for the other values that are going to be repeated, we just do dot dot and then the other instance of the struct, which is student1. And this lets Rust know that we want the other fields in Rust to be what student1 was. So it's going to change everything except from name and UIN to student1's values. Any questions about the struct update syntax? Okay, we're going to demo it real quick, just to go over what this is, because it can be a little weird. Okay. So we've declared our student1 here with what we saw in lecture. And this is what we could do. We could just say student2 is whatever these things are, and we can copy student1's values by using the dot notation over here. That makes sense. And now when I run this, did I do something again? I keep uncommenting my comments. All right, clear. Run. And we see the new student has these values from the print statement. But this is a lot of unnecessary code, and if we have a bigger struct with a lot more values, let's say we want the student's year, their major, and all this other stuff, it'll be a lot of unnecessary code. So instead what we can do is use the update syntax. By manually assigning the name of the UIN here, we can take student1's other values and automatically assign that to student2. So now when I run this again, we get the exact same output. The result's the same, but you have less code to write, and it's cleaner for anyone else looking at your code. And now I want to talk about tuple structs. So tuple structs are similar to a tuple, but the difference is that if we want to have a tuple of a specific type that we want to repeatedly use over and over again. So the main difference between a struct and a tuple struct is the fields don't have names, only types. And this is useful when you want to give a tuple structure a name. So for instance here, let's say we want to repeatedly use test scores or lecture reviews, like so. If we have the test scores as a regular tuple, we don't know what it is when we're going to recycle it again and again. We don't know its data type. It's just another tuple, similar with like lecture reviews. So a few key points about this is, notice that we only define the types that the struct holds. We don't give it a name like we do with a regular struct. This is just a random unsigned 32-bit integer, or signed 32-bit integer, sorry. We use round brackets or parentheses like we do with a regular tuple. And although these two tuples look the same, they're both their own individual type. So this is important because if you have a function and the parameter wants test scores, you cannot pass a lecture review to it because they're different types. So even though they look exactly the same and they have similar functionality, they are different types just because of the way we've declared them. But apart from these restrictions mentioned, they can be used like a regular old tuple. You can use dot notation to access the values, you can assign it to variables, etc., etc. Okay, so now we're just going to go through a pretty big Kahoot with everything we've covered so far. Yeah. All right, so here's the Kahoot code. please use your net ID when you log in to Kahoot. Okay, who is not in the Kahoot yet? Raise your hand. Okay. Okay, who is not in the Kahoot? Alright, is everyone in the Kahoot? Alright, then we're gonna start. Variables in Rust are blank by default. Alright, great. Most of you guys got that right. So variables in Rust are immutable by default. You cannot change them once you've assigned them. And that's done for concurrency and to make your code very safe. Alright, it's leaderboard. Remember, top 5 gets a whole 1% extra credit. All right, great. So I can get that code back. Okay. So if we use the mute keyword, that makes our variable mutable. That means we can change it. So now we can assign it to a new value, and when we print it, we'll just print 6. Okay, so scalar data types are like integers, strings, floats, and bools. Those are the 4 scalar types we have. They can only hold a single value. Compound data types are the arrays and tuples that can hold multiple, like a list. Any questions about this so far? Any of the previous questions? Just stop me if there are. Okay, great. Yep, arrays can only hold one data type when you're working with them. So if you put an integer and a float together, your array will crash. It's not going to work. This leaderboard. All right, so this one is from the second lecture of Rust. The stack can hold variables that we know the length of. So obviously this is false. Awesome, yeah. So if the stack can hold things that we know the size of, the heap is the opposite. It stores data of an unknown size or a size that might change. All right, great. Pretty self-explanatory. I don't know why we'd ever want to reduce performance. Programmers always want to make code faster, especially with Rust. So yeah, good job, guys. Okay, so false. A value in Rust can only have a single owner. If you have multiple, so once you hand over ownership to another variable, the original variable loses ownership of that value. Rust is a single paradigm programming language. True or false? All right, so Rust is a multi-paradigm programming language. That means you aren't restricted to a single kind of programming paradigm. So programming paradigm, as a refresher, is like object-oriented programming or functional programming. You guys are probably used to object-oriented because you're all working in Java, probably. So yeah, Rust allows you to code however you want, and not however way you want, but you're not restricted to a single style. Update in the leaderboard. All right, pretty easy. If you want to declare a struct, so if you want to define a struct, use the keyword struct. If you want to declare a struct, you use let. So that's a little bit tricky. Defining is like when you do over here. This is defining a struct. Declaring a struct is when you use it in your code, like this, with the let keyword. This one's a little tricky. Okay, so this one is a little hard. Functions will take ownership of the variables that are passed into it unless stated otherwise. So if you pass a string into a function, this, whatever variable that the function allocates the string now owns that string. So unless you specify otherwise, the function will take over ownership over that variable that you pass into it. We did this today. Yep, slices are references. So if you have a string, you take a slice of it, you aren't copying it and making a new thing. You're just pointing back to what you had originally. Update in the leaderboard. Yeah, so a struct, we use the dot notation to access the variable. So the blue answer is correct. Use dot and then the variable name. Okay, so when you declare a struct, you can either make the whole thing mutable or you can make the whole thing immutable. You can't just say the name is mutable, but the rest is immutable. The whole thing has to be either one or nothing. Any questions about that or any of the previous questions? All right, we'll move on then. Can everyone see the code okay? Yeah? No? That is a yes. Okay, so I'll walk through this. So we declared a string, which is a bunch of random letters, or A, B, C, D, up to K. We want to get a reference from 3 to 7. So if we count from here, 0, 1, 2, 3, that starts at, oh my god, at D, E, F, G, and H is the 7th, but we do not include the last thing. So we just have D, E, F, G. Whoever's first has been holding that for a long time, so good job. All right. Well, you're all correct. These are all correct examples of Rust, as you remember from the first lecture. I was hoping more people pick blue, but that's okay. All right, last question. String slices internally hold a pointer, length, but not capacity. True or false? All right, this is true. So a string slice, I can go back real quick. Okay, so a string slice only holds the pointer and the length, whereas the actual string as a whole will have the pointer, length, and the capacity. Any questions about that? Yeah. So the capacity is the amount that it can hold. So let's say we had like an array, for instance, and one of the last few item, or a tuple, sorry, one of the last couple items to be empty. The capacity is bigger than the size at the moment. We just want enough space later on to add characters to it. And we'll talk more about that when we talk about vectors, which can resize. There are arrays that can resize and are very smart. All right, let's look at the leaderboard. Also, top 5 will be getting 1% extra credit. All right, so good job to all you guys. That was a pretty long quiz, so good job keeping up with all of it. Okay, so that's everything from us. If you have any questions, you come up here and ask us. Do we have any announcements today? All right, no announcements either. If you have any questions, you can talk to us. Next lecture, we're taking a break from new Rust content. We're going to learn how to debug and code better in Rust, and then we'll get back into more Rust stuff. So enjoy your weekend.